Imagine taking a journey across the universe at nearly the speed of light. You leave Earth behind. You travel for what feels like a few years. You celebrate birthdays aboard your spacecraft. You watch distant stars pass by your window. You sleep, wake, eat, and live your life much as you always have. Then one day you return home and discover that everyone you knew has aged decades more than you. Your friends are old. Your family is old. Entire generations may have come and gone, while for you, only a handful of years passed. It sounds like science fiction, but according to modern physics, something very close to this could actually happen. Time, despite how solid and dependable it feels, is not as fixed as most of us imagine. It can stretch. It can slow down. It can speed up. And under the right conditions, two people can experience different amounts of time while living in the very same universe. The deeper scientists have explored the nature of time, the stranger it has become. Tonight, we're going to explore one of the most mysterious things any of us will ever encounter. Something that surrounds every moment of our lives. Something we can measure but don't fully understand. Something that every human being experiences, and almost nobody stops to think about. Time. Welcome back to the Snoozing Scientist. Before we begin tonight's journey, I'd love for you to leave a comment down below and let me know where you're tuning in from. Whether you're listening from a quiet countryside town, a bustling city, or somewhere on the other side of the world, it's always fascinating to see where our fellow sleepy scientists are gathering each night. Now get comfortable. Settle into your favorite chair, bed, or couch. And for a little while, let's think about something that has been quietly moving forward every second of your life. Time feels obvious. You probably don't spend much of your day wondering what time actually is. You check the clock. You know when you need to wake up. You know when you need to be somewhere. You know roughly how long a minute feels. Time seems so familiar that it almost disappears into the background. Yet if someone stopped you on the street and asked a simple question, "What is time?" you might find yourself struggling to answer. The great physicist Augustine of Hippo famously wrestled with this problem more than 1,500 years ago. He wrote that when nobody asked him what time was, he knew perfectly well. But when someone asked him to explain it, he no longer knew. And in a strange way, humanity has been wrestling with that question ever since. Because time is unlike almost anything else we experience. You can hold a rock. You can touch water. You can hear wind moving through trees. But time cannot be touched. It cannot be seen directly. You never actually observe time itself. You only observe things changing. A candle burns down. A leaf falls. A child grows older. The sun rises and sets. What we call time may simply be our way of describing change. In fact, some philosophers have argued for centuries that time isn't a thing at all. Instead, they suggest that time is more like a measurement, a way of organizing events, a framework our minds use to make sense of the world. Long before clocks existed, humans still experienced time. Ancient people watched shadows move across the ground. They observed the changing seasons. They noticed the phases of the moon. The passage of time was written into the natural world itself. A seed became a plant. Winter became spring. Day became night. These cycles became humanity's first clocks. And for most of history, that was enough. Imagine living thousands of years ago. There are no wristwatches, no smartphones, no digital clocks glowing beside your bed. The exact time of day is largely irrelevant. You wake when the sun rises. You rest when darkness falls. Your life is synchronized not to numbers on a screen, but to the movements of Earth itself. In some ways, that is how every living thing still experiences time. Birds don't own calendars. Trees don't wear watches. Yet countless organisms possess internal clocks that help them track the passage of days. Scientists call these circadian rhythms. Hidden deep within the brain, tiny biological systems help regulate sleep, wakefulness, body temperature, hormone production, and countless other processes. Your body is keeping time right now. Even if every clock on Earth suddenly disappeared. Even if you were placed in a cave with no sunlight. Even if you had no way to tell whether it was morning or night. For a while, your body would continue following its own schedule. Almost like a clock built from living cells. Researchers studying these internal clocks have performed fascinating experiments over the years. Volunteers have spent weeks isolated underground, completely cut off from sunlight and normal day-night cycles. No windows. No clocks. No phones. No outside information. And something strange happens. People often begin drifting away from the standard 24-hour day. Some settle into cycles that are slightly longer. Others slightly shorter. It's as though the body is trying to keep time on its own, but without the daily correction provided by sunlight. Which raises an interesting question. Why is a day 24 hours long in the first place? The answer has nothing to do with biology, nothing to do with physics, and certainly nothing to do with nature choosing a nice round number. Instead, the number traces back thousands of years to ancient civilizations that divided the day and night into smaller segments. Over centuries, those systems evolved into the hours, minutes, and seconds we still use today. And if history had unfolded differently, we might be living in a world where days were divided completely differently. The clock on your wall could have looked nothing like the one you know now. Which is a reminder that much of what we think of as time isn't actually time itself. It's human bookkeeping. A system of labels we invented to help organize something far more mysterious. Because beneath the clocks, beneath the calendars, beneath the schedules and appointments and countdown timers, there remains a deeper question. A question that scientists are still trying to answer. What exactly is time? And as we'll soon discover, the universe may have a much stranger answer than anyone expected. For most of human history, time seemed simple. The sun rose. The sun set. The seasons changed. Children grew into adults. People grew older. Everything appeared to move in one direction, at one speed, for everyone. It wasn't until the early 20th century that scientists began discovering something deeply unsettling. Time wasn't behaving the way they thought it should. The story often begins with trains. Not because trains have anything special to do with time, but because they helped scientists imagine situations that would otherwise be difficult to visualize. Imagine standing beside a railway track on a perfectly still evening. A train rushes past at tremendous speed. Now imagine that, at the exact moment the center of the train passes you, two bolts of lightning strike, one hitting the front of the train and the other hitting the rear. From your position on the ground, both flashes arrive at the same time. Naturally, you would conclude that both lightning strikes happened simultaneously. But what about a passenger sitting inside the moving train? That passenger is traveling toward one flash and away from the other. As a result, the light from the front strike reaches them before the light from the rear strike. From their perspective, the events were not simultaneous at all. Which person is correct? The observer on the ground? Or the passenger on the train? The strange answer, according to modern physics, is both. The universe does not always agree on whether two events happened at the same time. That realization shocked scientists, because it suggested that simultaneity, the idea that different observers share the same now, wasn't universal. The present moment itself depended on your motion. And if the present could change depending on where you were and how fast you were moving, what did that say about time itself? This was one of the ideas that emerged from the work of Albert Einstein. When most people hear Einstein's name, they think about genius, equations, or perhaps the famous image of him sticking out his tongue. But one of his greatest contributions was showing that time and space are woven together far more intimately than anyone had suspected. Before Einstein, time was often treated as a kind of cosmic background. A giant universal clock ticking away behind everything. After Einstein, that clock disappeared. In its place came something far stranger. Time became flexible, stretchable, dependent on circumstances. The faster you move, the slower time passes for you relative to someone moving more slowly. At everyday speeds, this effect is incredibly small. Drive across town and you won't notice it. Fly across the country and you won't notice it. Even astronauts aboard spacecraft experience only tiny differences. But the effect is real. It has been measured, verified, tested again and again. In fact, modern technology depends upon it. Far above Earth, GPS satellites orbit the planet at thousands of miles per hour. Every second, they send timing information back to receivers on the ground. Your phone uses these signals to determine where you are. But there is a problem. Those satellites are moving at high speeds and experiencing different gravitational conditions than people on Earth. As a result, time passes at a slightly different rate for them. Not by much. Just fractions of a second. Tiny amounts. Amounts so small they seem irrelevant. Yet if engineers ignored those differences, GPS systems would quickly become inaccurate. Your location could drift by miles. Navigation systems would fail. Maps would become unreliable. Every day, billions of people unknowingly rely on corrections for time dilation. One of the strangest predictions in all of physics has become so ordinary that it helps people find coffee shops and grocery stores. And movement is only part of the story. Gravity affects time too. This may be even harder to imagine. According to modern physics, massive objects like planets and stars actually change the flow of time around them. The stronger the gravity, the slower time passes. Right now, your head is experiencing time slightly faster than your feet. The difference is unimaginably small. Far too tiny to notice. But because your head is slightly farther from Earth's center, gravity is ever so slightly weaker there. And weaker gravity means slightly faster time. It's one of those facts that sounds invented. Something from a science fiction novel. Yet it is happening at this very moment. Every second. Every day. Everywhere on Earth. If you live atop a mountain, time moves a tiny bit faster for you than for someone living at sea level. Not enough to matter during a lifetime, but enough to measure with modern instruments. And scientists have measured it. Again and again. The deeper we look, the stranger the universe becomes. Because what seems like a simple question, what time is it, turns out to have no single universal answer. The answer depends on where you are, how fast you're moving, and even how close you are to massive objects. The clock beside your bed feels absolute, steady, reliable. Yet beneath that comforting rhythm lies a reality that is far more flexible than it appears. Time is not a river flowing identically for everyone. It's more like a landscape. A landscape that bends, stretches, and shifts depending on where you stand within it. And perhaps the strangest part of all is this: most of these discoveries are less than a century old. For thousands of years, humanity believed time was simple. Now we know that even something as familiar as a ticking clock may be hiding secrets we are only beginning to understand. As scientists continued pulling on the thread of time, they began to encounter a strange realization. The universe doesn't seem to care about the way humans naturally experience it. To us, the past feels fixed. The future feels uncertain. And the present feels like a thin line moving steadily forward. But when physicists write down the equations that describe the universe, something curious happens. Many of those equations don't actually care which direction time is moving. Imagine watching a video of two billiard balls colliding on a pool table. One ball strikes another. They separate. Everything seems perfectly normal. Now play the video backward. The balls move together, collide, and separate again. Oddly enough, both versions appear physically possible. The laws of motion work either way. If someone showed you only the collision itself, you might not immediately know which direction time was flowing. This puzzled scientists. Because our everyday lives feel completely different. You never see a shattered glass leap off the floor and reassemble itself. You never see smoke gather itself back into a candle. You never see yesterday returning. Time clearly seems to have a preferred direction. But where does that direction come from? The answer may lie in something surprisingly ordinary. Messiness. Or more specifically, a concept scientists call entropy. Imagine a brand new deck of cards. The cards are neatly arranged. Everything is organized. Now shuffle the deck. The order disappears. Shuffle again. And again. The deck becomes increasingly random. What are the chances that repeated shuffling would accidentally restore the original order? Technically possible, but extraordinarily unlikely. The universe behaves similarly. Over time, systems naturally move from order toward disorder. Ice cubes melt. Buildings weather. Footprints disappear. A hot cup of coffee slowly cools until it matches the temperature of the room. Everything drifts toward greater randomness. And this gradual increase in entropy may be the reason we experience time moving forward. Some physicists even call it the arrow of time. Not because time itself is an arrow, but because entropy points in a direction, toward the future. And once you begin noticing it, you see it everywhere. A child grows older. A candle burns shorter. A book gathers dust. Entire mountains slowly erode grain by grain. The universe is constantly changing. And those changes almost always move in the same direction. Yet even this explanation raises new mysteries. Because if entropy is always increasing, that means the early universe must have been extraordinarily ordered. Incredibly ordered. Far more ordered than the universe we see today. Which creates one of the biggest unanswered questions in physics. Why? Why did the universe begin in such a special state? What set the clock in motion? No one knows. And perhaps that's one of the reasons time remains such a fascinating subject. Every answer seems to uncover another question waiting underneath. As the 20th century progressed, scientists built increasingly precise clocks. Not wristwatches. Not grandfather clocks. Something far more extraordinary. Atomic clocks. These are among the most accurate instruments humanity has ever created. Instead of measuring time through gears, pendulums, or springs, they measure tiny vibrations occurring inside atoms themselves. The precision is difficult to comprehend. Some atomic clocks are so accurate that they would lose less than a second over hundreds of millions of years. Think about that for a moment. Entire species have appeared and disappeared over spans of time shorter than that. Mountain ranges have risen. Continents have shifted. Civilizations have come and gone. Yet an atomic clock could continue ticking with almost unimaginable consistency. And still, even these clocks are not measuring time itself. They're measuring change. The vibration of atoms. The repetition of physical events. In a way, every clock humanity has ever built does the same thing. A sundial measures the movement of shadows. A pendulum measures swinging motion. A quartz watch measures crystal vibrations. An atomic clock measures atomic oscillations. We never actually grab hold of time. We observe something changing and use that change as a ruler. Which leads to an intriguing thought. If absolutely nothing in the universe changed, if no stars moved, if no atoms vibrated, if no particles interacted, would time still exist? Philosophers and physicists have debated that question for centuries. Some argue yes. Others argue no. And the fact that such a fundamental question remains unsettled tells us just how mysterious time truly is. It surrounds every moment of our lives. It governs every experience we have. And yet the deeper we investigate it, the more it seems to slip through our fingers. Like trying to understand water while floating in the middle of the ocean. We're immersed in it. Dependent on it, shaped by it, yet somehow still struggling to explain exactly what it is. And as the hours pass and the stars continue their slow movement across the night sky, humanity's search for that answer continues. Tick by tick, question by question, year by year. still following one of the oldest mysteries we have ever encountered. One of the most famous moments in the scientific study of time began with a disagreement that seemed almost impossible to resolve. In the late 19th century, physicists believed they had a pretty good understanding of how the universe worked. Objects moved according to well-established laws. Light traveled through space. Time flowed steadily in the background. Everything seemed neat and orderly. Then a pair of scientists named Albert A. Michelson and Edward Morley performed an experiment that wasn't supposed to be revolutionary. In fact, they expected it to confirm what everyone already believed. At the time, many scientists thought light traveled through an invisible substance called the luminiferous ether. Just as sound moves through air, they imagined light needed a medium through which to travel. The experiment was designed to detect Earth's movement through this invisible ether. But something unexpected happened. They found nothing. No matter how carefully they measured, the results refused to cooperate with the theory. The ether seemed not to exist. For years, physicists struggled to explain the results. Then, in 1905, a young patent clerk named Albert Einstein proposed something radical. What if the speed of light was always the same for everyone, no matter how they were moving? At first glance, this sounds harmless. But it created a problem. A huge problem. Because if the speed of light never changes, then something else must. And what changed turned out to be time itself. The consequences were astonishing. Clocks moving at different speeds would disagree. Observers would experience time differently. The universe was not operating according to common sense. It was operating according to deeper rules that nobody had fully understood before. At first, these ideas seemed almost absurd. Many scientists were skeptical. But science has a way of forcing us to accept uncomfortable truths. Experiments kept confirming Einstein's predictions. Again, and again, and again. One particularly elegant test took place in 1971. Two physicists, Joseph Haefel and Richard Keating, carried highly accurate atomic clocks aboard commercial airliners. The clocks flew around the world. Other clocks remained on the ground. According to Einstein's theory, the clocks should no longer agree when the flights were finished. And they didn't. The differences were tiny. Tiny enough that nobody aboard the planes noticed anything unusual. But the clocks noticed. The clocks revealed that time itself had passed differently for the travelers. Imagine that. Not a theory. Not a thought experiment. Actual clocks physically experiencing different amounts of time. It was one of the first demonstrations that time dilation wasn't merely mathematics. It was real. A few years later, another fascinating discovery emerged from studies involving particles called muons. Muons are unstable particles created when cosmic rays strike Earth's atmosphere. The strange thing about muons is that they shouldn't really reach the ground. Their lifetimes are incredibly short. If time behaved the way people once assumed, most of them should decay long before reaching Earth's surface. Yet scientists detected huge numbers of them. The explanation turned out to be relativity. From our perspective, the muons are moving so fast that their internal clocks run more slowly. They survive longer than expected. And because of that, many successfully complete the journey through the atmosphere. In a sense, tiny subatomic particles were providing evidence for time dilation every day. Rain was falling. Clouds were moving. People were going about their lives. And invisible particles from space were quietly confirming one of the strangest discoveries in physics. As the 20th century progressed, scientists began finding even more unusual examples. One of the most important involved gravity itself. Einstein predicted that gravity should influence time. The stronger the gravitational field, the slower time should pass. This idea seemed incredibly difficult to test. After all, how do you measure tiny differences in the flow of time? The answer came through increasingly accurate clocks. In 1959, physicists Robert Pound and Glenn Rebka performed an experiment inside a tower at Harvard University. The vertical distance involved was only about 74 feet. Not a mountain. Not a planet. Just a building. And yet, they were able to detect effects caused by gravity influencing the passage of time. The difference was extraordinarily small. But it was there. Exactly where Einstein predicted it would be. Today, scientists can perform even more impressive measurements. Modern atomic clocks are so precise that if you place one clock on a table and another just a few inches higher, they can eventually detect differences caused by gravity. Think about how remarkable that is. A difference in height measured in inches. And time itself changes. Not enough for humans to notice. Not enough to affect daily life. But enough for science to measure. Enough to remind us that the universe is stranger than our instincts suggest. What appears constant often isn't. What appears absolute often isn't. And perhaps nowhere is that more evident than in time. The closer scientists look, the less it resembles the simple ticking clock imagined by earlier generations. Instead, it becomes something dynamic, flexible, connected to motion, gravity, energy, and the very structure of reality itself. And even after more than a century of experiments, discoveries, and observations, researchers still don't fully understand it. Which means that one of the most familiar experiences in your life remains one of the greatest unsolved mysteries in science. As strange as relativity can seem, some of the most fascinating discoveries about time have come not from space travel or giant telescopes, but from studying the human brain. Because there is a difference between time itself and the way we experience it. And those two things are not always the same. Think back to being a child. A single summer vacation felt enormous. Waiting for a birthday seemed to take forever. The school year stretched on endlessly. Yet as adults, many people feel the opposite. Years seem to disappear. Birthdays arrive unexpectedly. Entire decades can feel surprisingly brief. Scientists have spent years investigating this phenomenon, and while there is still debate about the exact reasons, several interesting ideas have emerged. One possibility is that the brain pays more attention to novel experiences. When you're young, almost everything is new. New places, new people, new experiences, new discoveries. Your brain records enormous amounts of information. Later, when you look back, those years appear rich with memories and detail. As adults, routines become more common. Days blend together. Weeks become familiar. The brain stores fewer unique markers. Looking backward, those periods can feel compressed, almost as if less time passed. It's a strange idea. The feeling that time is speeding up may actually be connected to memory. Not to clocks, not to physics, but to how the brain records experience. Researchers have discovered other peculiar distortions as well. During emergencies, many people report that time seemed to slow down. Athletes sometimes describe moments where everything appeared unusually clear and deliberate. Drivers involved in accidents often say events unfolded in slow motion. At first, scientists wondered whether the brain was somehow speeding up its perception during stressful situations. The reality appears more subtle. Studies suggest the brain may not literally process information faster. Instead, it records far more detail. When the event is remembered later, the unusually rich memory creates the impression that the experience lasted longer than it actually did. In other words, your memory of time and your experience of time are not always identical. The brain is constantly reconstructing reality, including time itself. And perhaps nowhere is this more obvious than during sleep. Have you ever had a dream that seemed to last hours? Maybe even days? Yet when you woke up, only a short amount of real time had passed. Dreams present one of the strangest examples of subjective time. Scientists still don't fully understand how the brain constructs the experience of duration while dreaming. A complex sequence of events can appear to unfold within a relatively short period of sleep. Entire conversations, journeys, stories, experiences, all occurring inside the mind. And although researchers have learned a great deal about sleep, dreams remain one of neuroscience's most fascinating mysteries. The relationship between time and the brain becomes even stranger when we look at certain animals. A fly experiences the world differently than a human does. So does a hummingbird. So does a dog. Researchers studying visual processing have discovered that different animals process information at different rates. To a creature with an extremely fast nervous system, movements that appear normal to us may seem slower. Some scientists believe this is why flies are so difficult to swat. The fly isn't necessarily smarter. Its nervous system is simply processing information more rapidly relative to its size. It's as though different creatures experience slightly different versions of the same world. Not different universes, but different tempos, different rhythms, different streams of time perception. Meanwhile, elsewhere in science, another mystery was beginning to emerge. As physicists looked farther into space, they were effectively looking backward in time. This happens because light travels at a finite speed. When you look at the moon, you are seeing it as it was about 1.3 seconds ago. When you look at the sun, you see it roughly 8 minutes in the past. The nearest stars appear as they were years ago. Distant galaxies may appear as they existed millions or even billions of years ago. Every telescope is, in a sense, a time machine. Not because it allows travel through time, but because it allows observation of the past. The deeper we look into the cosmos, the farther backward we see. Some of the most powerful telescopes ever built are now observing galaxies whose light began its journey before Earth even existed. Before oceans formed. Before dinosaurs. Before the first trees. Before anything familiar to us had appeared. That light traveled across the universe for billions of years before finally arriving here. And now, for the first time, human eyes are seeing it. There is something remarkable about that. Right now, as you sit listening, ancient light from the distant universe is still traveling through space. Some of it may arrive tomorrow, some next year, some thousands of years from now. Messages from the deep past, still making their way across the cosmos. Which perhaps reveals one of the strangest truths about time. The past is never completely gone. Its light continues traveling. Its effects continue spreading. Its influence remains woven into the present. And every moment we experience is connected to moments that came before it, stretching backward through history and outward across the universe itself. The more we learn about time, the less it resembles the simple ticking of a clock. Instead, it begins to feel like something much larger. A thread connecting stars, memories, dreams, atoms, and entire galaxies. Something so familiar that we barely notice it. And yet so mysterious that some of the greatest scientific minds in history are still trying to understand what it truly is. There is another question about time that has quietly fascinated scientists for generations. If time can slow down, if it can speed up, if it depends on gravity and motion, then what happened at the very beginning? What happened to time itself at the birth of the universe? At first, this may sound like a simple question. Surely time existed, and then the universe began. But modern physics suggests the situation may be much stranger. When scientists trace the history of the universe backward, they eventually arrive at what we call the Big Bang. Not an explosion in space, as it is often imagined. Rather, the beginning of space itself. The beginning of the universe's expansion. And possibly the beginning of time. This creates a fascinating problem. People naturally ask what happened before the Big Bang. But according to some interpretations of modern physics, that question may not actually make sense. It's a bit like asking what is north of the North Pole. The question seems reasonable at first. Yet once you reach the North Pole, the concept of farther north stops having meaning. Similarly, if time itself began with the Big Bang, there may not have been a before in the conventional sense. Not because something prevented it, but because time itself had not yet emerged. Even today, physicists continue debating this idea. Some theories suggest time truly began there. Others suggest deeper structures existed before the Big Bang. Still others propose that our universe may be part of larger cycles, where expansion and contraction repeat over immense periods. At the moment, nobody knows for certain. And that uncertainty places us in an interesting position. Despite all our technology, despite our telescopes and particle accelerators, we still do not fully understand where time came from. Yet perhaps even more mysterious is the question of where time is going. Because while we remember the past, we do not remember the future. This seems obvious. Of course we don't. But why? Why is memory one-directional? Why do causes come before effects? Why does time appear to flow toward tomorrow instead of yesterday? Physicists often refer to this as the arrow of time. And while entropy explains much of what we observe, there is still debate about why our conscious experience follows that arrow so consistently. Your memories point backward, never forward. You remember breakfast. You do not remember next week's lunch. You remember childhood. You do not remember retirement. The future exists as possibility. The past exists as memory, and somehow, consciousness moves between them. Or at least, that's how it feels. Some researchers have even suggested that our perception of time may emerge from the way memories are formed. The brain stores records of previous states but not future ones. As new memories accumulate, the sensation of moving through time emerges naturally. In this view, what we call the passage of time may be deeply connected to the way information is recorded. And information, surprisingly enough, has become one of the most important concepts in modern physics. The deeper scientists investigate reality, the more information seems to appear at the center of everything. Black holes, quantum mechanics, thermodynamics, computation. All roads seem to lead back to information. Some physicists have even proposed that information may be more fundamental than space and time themselves. Imagine that for a moment. The clocks on your wall, the years of your life, the age of the Earth, the lifetime of stars, all of it emerging from something even deeper, something beneath time itself. It sounds almost philosophical, yet it is an active area of scientific research today. Meanwhile, on the largest scales imaginable, time continues unfolding across the cosmos. Stars are born. Stars die. Galaxies collide. Black holes grow. Entire solar systems form and disappear. And all of it occurs over timescales so vast that the human mind struggles to comprehend them. Our recorded history spans only a few thousand years. Civilization itself is a tiny moment compared to Earth's history. Earth's history is a tiny moment compared to the age of the universe. And the universe itself may continue existing for trillions upon trillions of years into the future. Long after our species is gone. Long after our planet has changed beyond recognition. Long after the stars visible tonight have faded from the sky. Time will continue. Or at least, that's what current science suggests. There is something strangely comforting about that. The realization that we exist within a story far larger than ourselves. A story stretching backward toward the beginning of the cosmos and forward into futures no one will ever fully witness. Every second you experience is connected to that immense timeline. Every heartbeat, every memory, every sunrise, every conversation. A tiny moment in a universe that has been keeping time for nearly 14 billion years. And despite all we have learned, despite centuries of discovery and countless scientific breakthroughs, time remains one of the deepest mysteries we know. We can measure it. We can predict it. We can watch its effects unfold around us. Yet the closer we examine it, the more elusive it becomes. As though the universe is gently reminding us that some of its greatest secrets are hidden within the things we think we understand best. And so, as our journey through time begins to slow, it's worth reflecting on just how unusual this subject truly is. We set out to explore something that seemed familiar. Something so ordinary that we rarely stop to think about it. After all, time is everywhere. It fills every day of our lives. It governs our schedules, our memories, our plans, and our stories. Yet the deeper we looked, the stranger it became. We discovered that time is not the universal clock humanity once imagined. It bends beneath gravity. It stretches with motion. It flows differently for satellites orbiting Earth than it does for people standing on the ground. The universe itself cannot always agree on what events happened at the same moment. Even the simple idea of now turns out to be more complicated than it first appears. We explored how our brains shape our perception of time. Why childhood summers seem endless. Why years appear to pass more quickly as we grow older. Why dreams can feel like entire adventures unfolding in the span of a single night. We followed scientists as they carried clocks around the world, measured tiny distortions in time, and peered across billions of years of cosmic history using light that has been traveling through space since before Earth existed. And through it all, one remarkable truth kept appearing. Time is not merely something we measure. It is something we experience. Every memory you possess exists because time passed. Every lesson you learned. Every friendship you formed. Every place you've ever been. Each one is woven into the fabric of your personal timeline. In a sense, your life is a collection of moments gathered together across time. Thousands upon thousands of ordinary days. Most of which seemed unremarkable while they were happening. Yet together, they create a story unlike any other. Perhaps that's why time feels so meaningful to us. Not because of physics. Not because of clocks. But because time gives shape to experience. Without it, there would be no beginnings. No endings. No growth. No change. No stories to tell. And maybe that's one of the most beautiful things about it. The universe may not fully understand itself. Scientists may continue debating the nature of time for centuries to come. New discoveries will be made. Old theories will be challenged. Questions will remain unanswered. Yet despite all that uncertainty, every human being shares the same experience of living moment by moment through an ever-changing world. A world where stars are born and die. Where seasons come and go. Where memories accumulate quietly over the years. Where tomorrow slowly becomes today. And today slowly becomes yesterday. As you listen now, another second has already passed. Then another. And another. The same gentle rhythm that has carried every living thing through its existence continues onward. Not rushing. Not slowing. Simply unfolding. The clocks will keep ticking. The earth will continue turning beneath the stars. Morning will arrive. Night will return. And somewhere, far beyond what we can see, the universe will continue its own vast journey through time. Thank you for joining me on tonight's exploration of one of the greatest mysteries in science. I hope you've enjoyed wandering through the strange and fascinating world of time. And as this day gradually becomes part of the past, I hope you can take a moment to appreciate just how extraordinary it is that we get to experience any of it at all. Until our next adventure together, sleep well, stay curious, and remember that every moment, no matter how ordinary it may seem, is part of a story that has never existed before and will never exist again. Good night.